So today, I was never familiar with the term OEE. I think it's a bit of a tongue twister. Overall equipment effectiveness, it's a bit of a tough one to get your head around. But I think that Sam and Evocon have really simplified what this is all about. And I don't know when I came across Evocon, but I saw this really good visual display somewhere, and I think I got in touch with the guys to learn a bit more about what the application was. And lo and behold, they said to us, "Oh, there's a couple of Irish companies around the Dublin area," and one was W.Howard. So we went off down to see W.Howard and the application of Evocon, and met the team down there, and it was, again, they were very complimentary about it. So and then Barclays came on that visit, and they decided to give it a go. So we have Dave from W.Howard, and we've got Mick from Barclays, and they're going to just talk about the application of OEE in a very real case study. And I'm going to get Sam to introduce just what OEE is and what the product is, and then we're going to get the guys to talk about an application. And if you have any questions, throw them into the chat. We're going to record this session as well, so again, we're going to put it up on our YouTube channel afterwards. And when I put it up on the YouTube channel, I'll give you the contacts for all the guys as well. So if you want to talk to, I didn't tell them this anyway, but if you want to talk to Mick or Dave or Sam afterwards, feel free to contact them. Okay, so with no further ado, Sam, all the way from Tallinn in Estonia, is going to kick it off. Well, he's not originally from Estonia, but he can introduce himself.
Yeah, that's where I am now, but I'm British, from Wales. All right, thanks, Steve. So I'm going to share my screen now, so just give me a moment. I'm not very good at multitasking, so let's get this slide up and then I'll kick things off. Okay. So, Steve, can you confirm you can see this slide and just the slide? Can you see all your faces or not, or is that's not on there? Because I've got the... You can only see the slide.
I can see your slide. Well, I've got faces on slide. Depends on everybody will have their own kind of layout, I think. But your slide's fine.
Okay, good. Just so it's nice I can see everyone. All right. Well, yeah, thank you very much. It's really nice to have this opportunity to have this meeting with you all. So as Steve said, I'm going to have about 10 minutes at the start just to give you a bit of an introduction, not necessarily to Evocon, because I said to Steve, I don't want to come into this session and have it as a sales pitch in any way. So I just wanted to give a little bit of a high-level introduction into what OEE is. Then I wanted to tell a little bit about how you can get the real picture into factory performance. Something that's kind of close to my heart from my experience of when I was actually on the shop floor. I wanted to talk a little bit about the challenge of digital transformation and a lot of the buzzwords that we have to put up with around that space, and then finish up with some steps about if you did want to take the leap and what type of things you might want to consider. So just a quick introduction to who we are. We are a production monitoring tool, and one of the main KPIs that we're trying to get companies information for is OEE, which stands for Overall Equipment Effectiveness. Based over in Europe, actually based in Estonia, but actually we have a global spread. For this sector that we're in, we're kind of old hats at it. There's quite a lot of other competitive systems out there, but Evocon has been around for over 15 years. But yeah, very big in Europe. We've got a lot of interest over in the US, but there isn't any continent that we're not present in now. And when it comes to industries, we are kind of industry agnostic. So today we've got W.Howard, who are involved in the timber industry, and Barclay, who are involved in chemicals and fertilizers. But we work with food and beverage companies, construction materials. It's really quite broad. So that's one nice thing about the system. But let's talk a little bit about OEE. So overall equipment effectiveness, what is it? In simple terms, it's a score that tells you how much you actually produced in your factory compared to how much you could have produced under the ideal conditions. So a high OEE signifies an efficient factory operating at peak productivity, and a low OEE means there's what we call a hidden factory. Well, when we're talking about a hidden factory, what does that mean? It means there's unused resources that are producing losses where there could have actually been value. So as an example, if we say that your OEE is 60%, then you produce 60% of what's theoretically possible to produce in the factory. So that also means that there's 40% is your so-called, what we say, hidden factory, the capacity that you already have, but you're not utilizing. So this is why understanding your OEE is so important, because it shows how much you could have potentially produced with your current setup just simply by improving processes and before you might need to invest in in more resources. But I'm aware that a lot of people in the call today are probably familiar with OEE, so I didn't actually want to spend the time going too deep into what OEE means. I have got a very nice video that I recorded. It's on YouTube. Steve, I guess you're going to share the slides with everyone after the meeting, or not?
Yeah, absolutely. No, we can share all the material with your permission. Yeah, absolutely.
Okay, great. So Steve will share this, and there's the link there. You can also find it on YouTube by just searching for Evocon. But that one I go a little bit deeper into, how OEE is calculated. But one thing I was going to say is, one of the things I see quite often with our custom manufacturers who are measuring OEE, one of the main points that often gets missed is performance. So I will just explain a little bit. Availability is the total amount of running time that you have for the machine. So over a 10-hour shift, out of those 10 hours, how much was the machine or the asset running? Performance is when the machine was running, how well it was running. So how many short stops or slow running there was, and quality takes into account scrap and rework. I know Dave's going to spend a little bit more time in his section explaining a little bit more about that. But yeah, if you wanted to have a look at that video, maybe after you watch the last episode of Stranger Things, you can take a look. But what I wanted to talk about a little bit more is, if we leave OEE aside, what's the real purpose for an automated production monitoring system such as Evocon? And I would say the real reason is to get visibility and actionable data, whether that's OEE or the other metrics that we're collecting information about. It's really about having the right tools to aid communication, for you to be able to foster that kind of Kaizen culture with all of the stakeholders. And for us, that really hinges on the shop floor operators, the team who are actually at the front line. And on this slide here, I have an image from one of our clients, Nova Packaging. And you can see on the screen, there's displays above some windows. And these windows are actually looking out onto the shop floor. But for them, it's not just about giving the executives, in the office visibility and tracking nice KPIs and nice dashboards. They actively, encourage transparency and teamwork with everyone. And they do this by focusing on clear data and involving the operators so that they can make real progress by focusing on small and incremental gains. But, as I said, I've been there, and I used to work on the shop floor and understand how challenging it can be to get good data. And I also know when it comes to digital technology like this, it can actually be quite overwhelming about knowing what path you should take. So here, I just wanted to highlight a little bit about all the buzzwords that we hear from this sector. So if you look at the screen here, some of these probably be familiar with you: Industry 4.0, AI, machine learning, OT, IT, digital threads. It's mind-blowing, really. And I'd say in the IT sector, they definitely love a good acronym. But from my perspective, this just adds a lot of noise and creates a bit of a disconnect between actual tangible solutions. And there is another term that you might have heard of or might be able to relate to, which is called technology paralysis. And in short, that means, feeling overwhelmed by too many digital choices and being concerned about whether you're making the right decision. But it doesn't need to be that complicated. So at Evocon, we have put together this 8-step plan about what you should consider if you were thinking about implementing a system like ours. And if I start with this top here, really important to define the why. What is it that you're trying to achieve? Next, make sure you assign a good champion, someone who can lead that project from start to finish. And the third one, I'm going to spend a little bit more time here: secure understanding and buy-in. So with systems like Evocon, it's really important that everyone in the organization understands what you're trying to achieve, that it's not a big brother system that's going to be there to crack the whip, that it's actually something there for everyone to be able to share the challenges and improve together. Then the next one about choosing a pilot. Whenever I meet with new customers, I'm always telling them to do it in stages. Don't try and bite off too much at the beginning. Choose an asset that you want to focus on, break the project into stages, and set those goals. Then you want to be able to make sure that you can build trust in the data before you then roll out and refine it and add more assets in the future. So that was kind of my part that I wanted to cover at the start. I think everyone's really interested to hear more from actual real life examples from Dave and Mick. So just before I wrap up my section, I just really wanted to say thanks again. And really, although I work at Evocon, there are a lot of other alternatives for you to consider. So if this was something that you wanted to look into, you don't have to obviously come to Evocon, but if you did want to, it's a subject that I'm really passionate about, and I would love to speak to any of you more about this. On the screen, there's a QR code that you can scan to get my contact details, or you can drop me a line at sam@evocon.com. But the main thing is solutions like this can really have a big impact on your operations. And yeah, if you'd like some help with it, then I'm here.
Thanks, Sam. No, I totally back that up. I mean, it reminds me of a company we worked with where they didn't measure OEE, and they've just spent quite a sum, piece of capital on a new piece of equipment, and we began measuring it, and to their surprise, it was 29% OEE, and that was shockingly low. But and a lot of it was changeover and setup and all this sort of thing. But over a period of maybe 3 months or so, they got that up to 48%, and you know, that was an initial kind of quick win stuff. But having a piece of capital that you spent a lot of money on running at 29% versus 48%, it's almost like having, it's not quite double, but it's almost like having a second machine in terms of output. So really important that if you don't understand how well all this asset that you spend money on is actually performing, it's well worth investing in. So with that in mind, I think Dave is going to give us a really practical case study about how W.Howard have actually implemented this. So Dave, I'm going to hand over to you.
Okay, thanks, Steve. Can you hear my mic? Everything working?
Perfect.
Right. Okay, thanks, Sam, for that. That was quite good as well. And just one thing you mentioned there, I thought we'd touch on is that Evocon is not a big brother system, but it's very much information sharing, because we have all our screens on the lines. So all the information that Evocon captures is now out there for everyone to see. So it's not a management tool. It's not watching every individual on the line. It's the whole thing. Everybody gets to see all the information that we can share on it. So it's very much an information sharing tool as well as capturing. And as of course, as my boss told me years ago, if we're not measuring, we're not managing. So the OEE is a great measure of all three things that we are doing. So I'm just going to share my screen here if I have it right.
Yeah, that's perfect, Dave.
Okay. So just a little about ourselves here. So we make architectural moldings and skirting boards, architraves, that kind of thing. Windowsills, door frames, all from MDF. But this is not working for me now. Oh, sorry, no, I'm just going to have to stop for a second. My screen is frozen. Can we still see that?
Yeah, that's back again.
Back. Okay. Okay, so here we are. So
there we go.
The plant is here. The plant is here since around 1988. I started here in 1995, so I'm a bit of a long haul here. We've seen lots of different changes and things. But what we do is MDF architectural moldings. So we supply all of Europe and Ireland market. Okay, but since Brexit, we've been bought into by a UK customer, a UK company. So we have 4 sites in the UK actually, and in Kildare. So Kildare does Ireland and Europe, and of course the 4 UK sites just stay within Europe because of Brexit. So it's a big enough outfit, but we use Evocon in both UK and Ireland. And so we have 4 production lines here. We currently have Evocon set up on 2, which is just brilliant, but we'll have to change. We're initially getting line 3 currently set up with Evocon. So some of the slides I'm going to show you in a few minutes will only be related to 2 of our 4 lines. The rest is kind of a manual recording system. So from our dust that we generate from making our MDF architectural moldings, we then kiln dry tropical hardwoods that we import with so we burn our dust, generate heat the factory and heat our kilns. So we have 60 staff in Ireland and 4 sites in the UK, as I said. So that's a little about us. We're kind of a small enough plant, but we've got a lot going on. We're quite busy. And now I can't go to the next slide. Okay, so overall equipment effectiveness. So there's a couple of things in it. There's 3 measures that we take. So our first measure is a measure of how we use our time. So as Sam was saying, availability, performance and quality. So in our time, let's just suggest we are working in a shop for 10-hour shift and the shop is completely empty for 5 of those hours. So that means we're available for 10 hours, but our actual availability to sell is only for 5 hours. So our availability now has already become down to 50%. And that's one measure of our time. So the next measure is how well did you perform in that time? So let's say in the 5 hours out of the 10, we got 20 customers. But let's say I was rude to 10 of them. So only 10 customers out of the 20 actually purchased an item from us. So from the 50% of the time, we've now only made 50% of the possible sales. So and the last measure is the measure of quality in that performance. So in then 10 sales that we sold, were the 10 products good? But if they're not, let's say 5 products came back. So now we've only performed 50% of quality in the 50% of performance in the 50% of the time, which would give us an OEE of about 12.5%. So I would never make a very good salesman. So OEE, availability by performance by quality. So the first orange bar there is our available time. So let's say that's your entire working week of your machines, regardless how many shifts you have. It's your entire possibility of running your machines. So the second line is your availability minus your availability losses. So that would be like when your shop is empty with no customers. That would be called an availability loss. But in manufacturing, it could be change in product, it could be a breakdown, it could be no electricity, it could be any of those unscheduled stops that you're available, your staff are available, your lines are available, machine is available, but you're not actually running. So if you take the availability losses, that gives you a percentage of availability. So then you take that with your performance. So let's say for the time that you are available to actually run, are you running at the right speed? Have you any idle stops, waiting on forklifts, little small things that are not really breakdowns, but things that stop you making 100% of the available time that you have. And then of the product that you have made, you then will have good quality and bad quality. So you will have quality losses. So that gives us the availability by performance by quality. And that is your OEE figure. So it's really only a measure of 3 things. Your availability, how well you performed when you were available to run, and how much good quality product came out of that performance. So those 3 things can be whittled down to 6 big losses, they're called. So your availability is either a planned stop or an unplanned stop. So you either have a planned stop would be changing product or lunch breaks or whatever you decide, you're going to put a new gearbox into a machine at 5 o'clock till 7 o'clock. So you can plan that stop. And any unplanned stop would be your breakdown, things like that. We recently had no electricity for about 10 hours in the plant one day. So all those planned versus unplanned, they all come into availability. So unplanned stops is kind of where you need to be looking. Planned stops are generally your resets and changing products and stuff like that. But unplanned stops would be out of your control. So if you have a preventive maintenance system, your unplanned stop should come down. So it's 2 of your availability. Your performance then is speed. For us in the timber industry, it's generally tooling that slows us down. So if we're not running at optimal speed, it's generally down to tooling. Is our tooling sharp enough? Is it made from the right thing? We have tungsten carbide tooling or diamond tooling, different things like that. So that's a speed performance issue. And all other small stops, little idling stops, little adjustments on the line that need to be stopped. If you have to open the hood of any machine on the line for safety to do any adjustments. So those 2 performance, so they're not really unplanned stops. They're definitely in your performance between speed and any idling stops, silly little things. So that is the performance of what you're actually running in the time that you have available. And then that brings us to quality. So quality is really only 2 things. One is scrap, must be thrown out, but one is rework. So that can fall into an unplanned stop as well, because you're actually using the line twice to make the one product. But for us, it falls into quality. So scrap or rework. So, I mean, those are your nearly 6 biggest losses of any factory, any manufacturing industry. It will probably fall into one of those 6. And any of those 6 obviously are whittled down to the 3, availability, performance, and quality. Okay, so for us, what that means is, so this is Evocon. If you haven't seen Evocon, this is some of the figures Evocon gives us. So if you look at the tile on the top left-hand side, so this is for production line 1 and line 4 for us over a 7-day period. So our availability was only 63%. So you can see that by the outer green circle. But our performance, so of that 63%, we performed 86.5% in total of what our target speed was, which is kind of reasonable. And in that performance, 99.07% of that was good quality product. So there's 3 measures that we spoke about, but one of ours is quite a problem, is the availability there. So if you look at the tile underneath that circle, we have our downtime for the last 7 days. So the first one there is 12 hours, 31 minutes and resetting a molder. So that is changing product. So that seriously brings down our availability. 12 hours changing products in a 7-day period is, it's quite a chunk of time. And that's represented by 63%. So the second one underneath that reset molder, the red one there, is one commented, that was when we lost electricity for, it looks like nearly 11 hours there. So that brings down our availability. So our performance then comes down to see the adjustments and outfeed adjustments, molder adjustments. They're the little things that if you set your line right, you won't have these little stops. So we spent 2 hours, 53 minutes on that and 2 hours, 7 minutes on the bottom one. So that one, it's a measure. It's a real measure of live, actual facts of what's happening. And Evocon gathers this information and throws out this report. So, to know we spent 2 hours and 7 minutes adjusting the outfeed is a good measure. So then we can go to the operators and say, is there a problem? Is it not working? Do we need maintenance? Whatever it is. But without that measure, you kind of just go week to week with that loss. So if you look at this middle tile at the top, that is our OEE for 30 days. So the one on the left was for a week. The OEE on the middle is for a month. So if you look at the tile underneath it, again, the reset molder is our biggest loss. So again, availability is another huge problem over the month. So it's not just a 1 week thing, it's over a month in this. So 66% available. Of that 66%, we performed 86.35% of our target speed, and our quality of that performance was 99.23. Now, that's a really good quality figure, but again, it's the availability that lets us down. So what we did then is I went into just to get 1 month on line 1 and line 4. So again, it's around 56% OEE for a month, which is not exactly where we need to be. We'd like to be at 65% or over. So we went to the downtime again. It was resetting and resetting. The second one is again. So we've huge times on resetting molders, and that's our main loss in a lifetime factory. Main loss is availability. Everything else seems to be okay, but the availability is wrong. It's not. It's just not where we need to be, as a high class production factory. If you look at the bottom 2 on the left, so there are 35 minutes and 56 minutes of adjustments. So that is our performance. So our availability is huge, but performance is quite small, what we need to look at. So what we've done then from Evocon is we've taken our OEE since January just to see what's been going on. So if you look at the top orange line, that's our quality, and our quality for the whole year seems to be around 99%. So we're quite happy with that. Our performance seems to be somewhere between 80 to 90. So we're reasonably happy with that. The next line down, the green trend line is our availability, and that really 70% availability is the biggest percentage we've had since January. So that is a real problem for us. And in the last 2 months, it's taken a drop and a drop, which of course brings down the bottom one, the OEE of the black line. So somewhere in the whole year, we're only at around 57, 58% OEE. And in the last 2 months, October and November, when I did this, we've taken a real drop. So what does that figure tell us? So what we did is I took these figures out into Power BI, and I decided that our availability is our biggest problem. So why is that happening? So I went to look at how many resets per line. So we have 2 lines measuring here. The top blue line is line 1, and the lower blue line, dark blue line, is line 4. But of course, both of those trends are going up, and that is the number of resets per line since January. So all year we can say our availability has been dropping down all the time, but our resets have been going up. So we've been getting more products, more product changeovers, shorter batch runs, whatever it is. But that is where our availability is coming down. And here's why. It's because the number of resets per line is going up. So the bottom one, then, we decided we would have to do something about this. So we introduced a single minute exchange of dies project on both the lines, because if we have more resets on the lines, we have more downtime. But if that's market driven, we have to adjust to that. We have to amend how we run. So we decided we'd do what we could to bring down our reset time, because we're going to get more resets. If that's the customer wants, that's what the customer gets. So it's up to us to manage that. So that is why on our OEE, everything else seems to be quite good. Our performance and our quality, but our availability is dropped, and it comes from a customer driven market. So I hope that kind of makes sense. So from the information given to us from measuring our OEE, we can clearly see that our main problem is availability. So OEE has given us the main focus of our problem. So it's given us our main focus of our problems, that our availability is just going down all the time. And then when we exported that and looked at it, it's because we have more resets and more changeovers than ever. So it's going up all year. So I went to the commercial people, and so the market has changed for us, and that is the way it is. The customer wants that, it demands that, shorter batch runs, more different SKUs. It's the way it is. So sometimes you can't control the market, but we have to react to it properly. And our measuring our OEE from Evocon has given us that, because we have actually brought in our single minute exchange of dies to bring down our changeover time, because we can clearly see, I mean, it's visual, we can see our quality and performance are fairly reasonable, but it's availability that is bringing our absolute figure down, our OEE down. So thank you for your attention. And that is us, and that is a lifetime use of Evocon and use of OEE. How we use it, we can use it more. You can always use it more, but that's pretty much what we do.
That's great,
Any
Dave.
questions on that?
We'll take questions in our chat. And one thing I was going to ask you about, actually, because I know when we went down to see you down there, and it's a while back, you were talking about how well the system was accepted by the people there.
Yes, because you can
explain
see
a bit.
Yeah, you can clearly see, so it's on each line. So you can see your target per the day. You can see, at 12 o'clock, halfway through your shift, you can see whether you're on target or falling behind, or do you need to do a serious recovery after lunch, or, you can see the ahead. It's just really information sharing as well as measuring, but it's really for people to see. It was great. Yeah, it was good, yeah.
Thanks, Dave.
Yeah.
We're going to move on to Mick and Barclay, Barclay Chemicals, another family-owned business in West Dublin. And so, Mick, I'm not too sure. Do you want me to present on your behalf, or are you going to share the slides?
No, Steve, if you can present on my behalf, again, similar, we just kind of have some IT issues here going through the laptop, so I'm connected direct to the room. So if you could share on my behalf, I'll just prompt you as we go through.
Okay. Yeah, can you all see that?
Yep.
Right, off you go.
Yeah, guys, again, I just want to follow on from what the guys were saying. I hope you just got a kind of detailed kind of overview of what OEE is. In my presentation, I'm kind of going to speak about how we move from a manual OEE recording system to automation. And it's just kind of what Sam was saying. It's kind of as part of our digital transformation. It's just making sense for the automated system. So as I go through the presentation, I'll show you how we transitioned. Just a little overview of Barclays. That's kind of our site here, our footprint in Damastown here in Dublin. We're a family-owned business. We manufacture and pack chemicals for the agri industry. We're 100% family-owned. Steve, just want to just click on through there.
Yep.
We were established in 1979. We're 100% family-owned. We're here in Dublin, and we're present in 33 countries around the world. We've producing on average about close to 1 million litres a week of chemical leaving here for the agri industry. And just done a little slide there on some of the products we help protect. There's some well-known brands here. Steve, you just want to kind of move on. It's kind of, you know, some brands we help protect while these are still in the ground, while the crops are still in the ground. There's some kind of well-known brands in Ireland. So it's just how we influence in the food chain, where we come into it. And I suppose just from our point of view, it's kind of giving an overview how we move from a manual OEE process to automation. Back in the day, we as a company we felt OEE was a good measurement of how we were. As the guys have said, it's like it's performance. It's like kind of your score. And the guys went in detail through what OEE stands for. We had a manual setup here. It was you can see there it was printed out templates. It was spreadsheets with formulas built into what Dave and Sam have kind of spoken about. Your availability, your performance, and your quality built into the background. But we were using templates on a daily basis, and we were relying on manual input from the operators on the line. Now, the guys were going busy about their day. You might have a stoppage on the line, but you were relying on them to go back and manually make an addition into the sheet. And sometimes they were guessing, they were inaccurate because they were multitasking at the time. So we had data, but sometimes it was inaccurate, and we were trying to focus on, as Dave said himself, the big hitters. And sometimes you were getting inaccurate information. So we were kind of looking at how we could automate our OEE recording system. And it was back in when Steve was doing a visit to ourselves, on one of the Lyons visits, he says, "Boys, just have to look at this system. It's a no-brainer for you." And we kind of put on the long finger for a year or so until we went down and seen the guys down in Howard's. And myself, Sinead, our plant manager, and one of our engineers went down and we says, "We need to implement this as soon as possible." And I suppose just as when we implemented it, just to echo what the guys were saying, it wasn't implemented as like a big brother thing. It was implemented just to give us good visibility and accurate data throughout the plant. And back in, I think it was June, maybe 24, maybe 18 months ago, we decided to do a pilot activity with Evocon on one of our Lyons. And we was on our main line. It was probably producing about 80% of our volume over here every week. And as soon as we put it in, we could see vast improvements. Myself and Sam sat down a good couple of times, and he says, "Mick, your targets are way off here. You're getting inaccurate data. You need to up your targets." We kind of had them at ideal instead of optimum. And as soon as we changed to our optimum targets with the help of Sam and Evocon, was a game changer for us. We were kind of, the manual system was giving us kind of, as we said, guesstimated data. It wasn't accurate. So if you're going to try and implement an OE system, it's all about kind of having accurate data, because we kind of drive our kind of business through the data that Evocon produces for us. So as soon as we put this onto the pilot line, everybody, as Dave was saying, the operators, everyone was like, "Oh, can we get that on airline? We need this. We're still doing a manual system." So the operators, we have a team of 20, 25 operators down there running 6 lines. And as soon as this went in, they were like, "Well, we need this." And with the help of Evocon, we've now got it implemented on 4 of our 6 Lyons. Our 4 main Lyons run most days, and the other 2 are kind of ad hoc, so it doesn't make sense to put it on them at the moment. And we're actually looking at a solution out on our manufacturing side of things to put it out there. So I suppose the automated system, it was give us great visibility. We were able to up our targets, and then we were able to hit on our big hitters, and it was less paperwork for the operators to handle, which was a game changer for them. I suppose some of our the big, so you can move on there, Steve, please. The benefits since implementing it, we were able to put a focus on some of our big hitters, and a focus, some of them which was unknown to us, was our speed loss. And we were able to drive some improvements from our speed loss. So we'd have various different formulations that be going down the line. We'd set them up by different products. Well, you can sort of see there's little yellow lines going down. So we were saying, what's the speed loss? So we were able to delve into the reasons and then have that discussion with the operator. And they were saying, oh, the certain chemical is reacting different. It's foaming slightly, a different can combination. So we were able to have a little look and see, okay, what can we do here to optimize the machine to reduce them speed loss? So we wouldn't have had that visibility previously. We just had a piece of paper. We couldn't actually see the live data in front of us, which was a huge win. And on the other graph there, we kind of have our good running, a small bit of speed loss, and then we have our downtime reasons. So we'd always delve into each downtime reasons to see what's our main cause of downtime. Is there our changeovers? Is there reoccurring issues happening on the lines? So just as a team and working with the technicians, we're able to try and reduce that. You can go and see we kind of ran, that's a snapshot of probably a month's data there on the left, and we probably ran pretty consistent through that. So it's all about the visibility, and throughout the plant, everyone has visibility of Evocon here. So when we implemented it, we were able to challenge our targets, and across the 3 main lines there, you can see we've kind of increased the OEE target year on year, but mainly in the last 12 months since we've implemented Evocon, we've increased our OEE targets, but it's an increased OEE target of our optimum run rates. We were running that ideal run rates, and myself and Sam kind of chatted about this when we first he says, Mick, you have to really set this up to its optimum to get true data. And when we done that, we naturally seen kind of our OEE increase. But then we were able to look at the issues and reduce them as we were running. So it's kind of our transition from a manual to an automated system has increased our business output and our OEE target. I think it's about 10% there looking at that. So it's a huge benefit to us as a company implementing it.
So Mick, will I show the video?
Yeah, show the video of an example of how easy the application is.
So let me just set this up again. And just for explanation as well, when you're looking at some of the visuals there, each row that you see is actually an hour's
production, yeah.
So it's an hour's production, and the idea is that I'll just share this now. The idea is that you can look at each hour by hour, but effectively all it is a sensor on the line, and it's sensing products going past it. And you basically set the rate at which you expect that product to go past as optimum. Now, if it doesn't get a signal, so it's missed a signal, the first thing is it'll recognize as speed loss, and then if it doesn't see a signal for a certain amount of time, it'll recognize that as downtime. So the data has been automatically captured, and Mick's video here is just showing how the team themselves actually interact then with the system. So let me just share the window, make sure the sound is on. Okay, can you see that?
Yep. Go ahead, yeah. So this is a live scenario as of this morning on one of our packing lines. So we have shift start at 7. So what we have here is an uncommented downtime, and then a can went through, got a signal, the line got a signal. So what we've done here is we'll add in a reason for this downtime, and it's a planned stop, and it's line setup. This other portion here is the operators on the line are waiting on a batch to be passed from the lab, so they had to wait just for the chemical to get the go ahead to use. So it's downtime, add reason, general stop, waiting on batch. So we have to highlight when the line is, for whatever scenario the line is down for, and then you can see it's working its way up to the ideal run rate.
That's it.
That's kind of just a little snippet of how easy the system is to operate and how we record our stoppages. But it's kind of just gone full circle. It's the visibility the system gives us from moving from our manual recording system to the automated, and the feedback from our operators is unreal. They love it. And as I just said, we're going to be rolling it out in the manufacturing, but it just makes their life easier, and it's a lot quicker for them to put in their live accurate data, and we're setting them up to succeed on the lines, which is a game changer for us.
That's brilliant, Mick. I'm going to throw it open to question and answer. So we have a few students on here learning about OEE, so I don't know if it's made it any clearer. And there's a few manufacturing companies who might be looking at this as a potential way to look at, maybe review their manufacturing data. So who wants to kick off? Any questions at all?
Steve, it's Alex. Just to start, how do the colleagues who have influenced, how have you baselined your speed? What's the process you go through to decide what is optimal speed or the achievable speed?
So as Steve said there, it's a sensor on the line, and Alex, our business is it's all can units, individual units going past. So ours ultimately is cans per minute, and we try and optimize our machine to run at cans per minute. I think from when we visit Dave's, it was the lengths of timber that they produce. So it's all kind of per signal per minute, per unit going past, and we gauge that too. So our fillers run at a certain speed per formulation of chemical going through, and it's on a rotary basis, so we kind of know the optimum that is. The signal should be receiving a can every 2 seconds, 3 seconds, and as it's set up to flag anything between 30 seconds and a minute of if it doesn't see a can, it flags as a stoppage. So it's cans per minute is how we gauge our.
And I think it's one of the measures that the system gives you automatically that is often missed by companies. So you might have a line that looks like, yeah, it's in production, it's running okay, but actually it's only running at 80% of the speed it's meant to be running at. So somebody has maybe slowed it down for a setup or whatever. So that kind of thing, that's often missed by many companies. That's a huge potential loss, and it's up to each company to set what is their optimum production rate.
Yeah, and if I add to that one quickly. So quite often when we start working with companies, they think their ideal cycle time for product X on a line is, let's say, 10 units per minute. But then as soon as you actually connect Evocon and the sensors, you might see that there's instances where that product can be produced at 12 or 13 units per minute. So the way that you set the target speed is actually from the data that we can provide. But you have a bit of an idea when you start, and then very quickly you actually get the real data to help set your targets.
Yeah. Close to my heart, Darren's asked a question in the chat here, and I think Sam, I've asked you this before. Obviously, when we got physical sensors for physical products, that's okay, but very often, particularly you might share some experience in the likes of the food industry, pharma industry, we've already got machines that are capturing the rate of production. How do you connect in with those, or can you connect in with those to give us the same kind of information?
Yep, let me just pull up the chat as well. So Darren, yeah, we've got a mix of options. So in here, we heard from W.Howard and from Barclay. So they actually have different setups for what sensors we've got connected. So we typically what we do is retrofit new sensors to the line. So that could be optical sensors, encoder wheels, maybe relays into a PLC to get a signal for when a cycle has been complete. But actually, if you already have good data, so very typical in a factory, you might have some machinery that's already collecting good data that we can use, but you also might have other machinery that's 20, 30 years old. So in the case where you have modern machinery where there is already data that we could use for Evocon, we can tap into that and pull it straight from there. We don't necessarily always have to install sensors. So yes, it can speak to any existing databases, whether you're using OPC servers or plant historians, we can normally pull the information we need from that as well.
Is that okay, Darren?
Yeah, sorry. Yeah, that's good. And I suppose just a follow-up question was, do you guys carry out an analysis of current data? So could you look at a machine and be able to say, yeah, this is useful or not useful, or how would that work?
Yep, that's what we would do, Darren. So if we started speaking about the project, we'd ask you for some sample data, have a look if it's got the information we need, but really we just need a timestamp about when the production started, and then depending on what we're measuring, what the asset is doing, then we'll be able to pull out whether it's units, weight, volume or something. Then yeah, but you would send us some example data and we'd figure it out from there.
Perfect, good stuff, guys. Well done.
Yeah, and obviously each product would have its own optimum standard. So you'd program all that into. So depending on every time you do a changeover, you'd program in the new product, and the OEE be calculated on that basis. The students out there, is there any questions? Those doing their masters and they need to answer questions and write theses and papers. Any thoughts?
Hi, Steve. I did have one question for the gentleman that kind of spoke at the start that works for the molding company, but I think he's dropped. They were able to identify kind of where their issues were based on the software that was kind of implemented there for the OEE, but have they managed to come up with any solutions to kind of help increase their target goals and to increase their overall production in numbers?
Yes,
Yeah,
we have quite a few. We implemented a continuous improvement team in the areas that we felt we were falling down, such as our single minute exchange of dies, when we realized that it was resets and line stoppages, the changeover products that was dropping us down. So it also means for our unplanned stops, we can actually narrow it down to how many minutes per week one particular machine has been unplanned stop. So any kind of breakdown or, change gearbox or belts going, stuff like that. We can give that information to our maintenance team, and we can improve then our preventative maintenance, all by the minutes. Like I can print off a report from it, from our OEE to say, well, okay, we spent 10 hours changing product, but when we were running, we spent 4 hours because belts come off or the motor burnt out or whatever it was on any particular machine. So we can give that straight away to the maintenance. So mechanically, we can make sure our lines are operating, and then effectively, operationally, we can reduce our reset time, because we know our resets are going to become more and more, because that's customer driven. So all that data is all there in seconds, but you wouldn't have if you didn't measure OEE as performance and as breakdowns and as availability. In those three things, you wouldn't have those figures. All you would know is you're not producing too well.
Yeah.
Is that a help, or is that answer?
No, that was perfect. Thank you so much.
I think as well, from visiting the couple of companies and listening to Sam as well, what impressed me was the acceptance by the operation team. And it's funny, actually, if you look at Mick's example there, you can see that there's downtime waiting on lab results. Now, in my experience, if you're not capturing that information automatically, somebody at the end of the shift is going to say, oh yeah, we were waiting 10 minutes. They kind of make it up a little bit. Whereas the system is actually saying, we haven't seen a can for 14.5 minutes, it'll be absolutely exact. But then to be able to actually aggregate that over a week or a month And it's a very relevant one, Mick, because one of your people is just doing a project on making sure materials are actually approved and released before production happens. And again, and you can't tackle everything, but and I think as Dave showed there, you might look at your top 3 over the month and say, right, these are our top 3. Let's set up some projects to tackle these ones and see can we make an impact between this month and next month.
That's a thought there. I mean, how do you look at this data and say what the biggest loss is? Because each one has a slightly different factor. So is there an easy way of looking at your OEE and saying the top 3 are these? Is there, what's the best way of seeing that, shall we say?
We kind of capture it in 3 different segments. We'd have planned stops, we'd have unplanned, similar to Dave, unplanned stops, and then we'd have speed loss stoppages. So you're trying to tackle them kind of, you look at them from different kind of direction. Your unplanned stops are probably, breakdowns or something that's happened. Planned stops could be changeovers, but you've kind of, you would have smed out your changeovers and you'd have an ideal time. But you're taking an average. If we've done 10 changeovers and your changeover time is 30 minutes, but for some reason your time is excessive, that you're looking to see has something gone wrong in the process. Is there any reason? So that's a kind of planned stop, and then unplanned stops will be little breakdowns or stuff where you talk with the technicians to say, look, the machine's missing caps fairly often. We've had 100 stoppages this week. Oh, they're only 20-second, 30-second stoppages, but they all add up. And then you're trying to say, okay, let's have a look at that. Where the operator probably wouldn't have flagged that with a technician because it's only a few seconds. But at the end of the week, it all adds up. So we had that recorded as incidents, individual stoppages. So you're looking at the little minor stoppages as well to get rid of that. And then the speed loss is kind of, there might be something where a batch that could have just been a little bit of foam or something and you can't quite get the machine to its optimum. So we look at them from different angles and try and tackle them individually with various departments, what way we can do it.
Yeah, but I think the message you're giving me is, when you're stopped, your production rate is nil. Therefore, they're the things that you've got to kind of address. Probably first of all is the reasons for the stoppages.
Yeah.
Question. But I guess one of the points was in order to be able to see the wood between the trees, though, you have different layers to the stops. So you have the actual individual stops, but then those also go up to groups. So then you can say, okay, what groups are the main offenders? Different groups will carry different weight in regards to what you want to focus on. So there might be, whether it's planned or unplanned stops, but even in the unplanned stops, you might have organizational stops, which might be things for training and whatnot. So those are kind of accepted, even though they're unplanned, but then there'll be like technical stops where you're like, this is stuff that definitely shouldn't be happening, so let's focus on that. So there's different layers for you to be able to categorize the importance as well.
I think as well, from my experience years ago operating this, we actually had a real simple 10 categories, and the 10th category was other. And what we were trying to establish what were the key drivers and not make it too complicated for people to enter data. So again, you can make the system as easy or as complicated as possible. My recommendation at the start is keep it simple, so talk about categories of downtime, and then you can obviously drill into that over time. I see Emer has a hand up. Question?
Yeah, hey guys, can you hear me okay?
Yes, perfect.
Yeah. I find this really interesting. I'd be more on kind of service side of things. So it's kind of all new to me, but I'm just wondering, say, what was maybe the reaction by employees on the floor with introducing these types of things? Like, was it seen as a positive thing, or was there a bit of, effort made into communicating with them, this is help us get better and all that? Or was it kind of seen as micromanaging, and how you maybe balanced all of that?
Tough question. I think there is there's a certain element of people seeing it as micromanaging, but in general, it's well received because they can see the problems and they can see how the fix is coming. And what we did when we got our OEE and started to bring it down into the 6 big losses, so we could categorize it into 6 things. And then we got some of the people and we brought them in a room and we did a Ishikawa diagram. Do you know the fishbone diagram?
Yeah,
So
yeah,
that gives, I don't know, like, so the maintenance department got certain jobs to do. Some other people got other, you know, because it's written down and everybody gets something to do, and we come back a week later. So you're involved in the procedure, you're involved in capturing the measurements, and you're involved in the improvements, and then you can see the results on your screen and on your OEE. So you know, you develop people through from start to finish with it. It was a good thing. But
Yeah.
yes, I understand what you mean. People can see it as micromanaging, and but yeah, you probably have to develop those people, bring them into the problem, bring them in, listen to their ideas, and develop solutions with them. And then when they see the solutions develop out of it and it working and their OEE going up, and you know, they can feel quite proud that they've
Yeah.
helped.
I think, sorry, Emer, just as Dave says there, I suppose if you involve the people, so if you think we have a pretty driven team here, and if they're on the line, they kind of just want to come in, get the line operating, get it running, get through their schedule, and the last thing they want is stoppages on the line. They want to just get in and get their day. But if they can't kind of capture the reasons why it stopped, you're kind of, not that you're going back to them and asking the question why, because it's not their problem. They just want to, but you're trying to just giving them the visibility to say, look, I'm here to do my job, but this is the reason why this is stopped, and they're putting the reason in for the stoppages. So it's actually empowering them to actually to give them a voice, but through a system. Not that we don't, you know, everyone, and then we go off and look at the reason and develop them, but they actually, it was pretty well received here with all our team.
I think it sounds great. So I was just kind of wondering from, say, another point of view what it'd be like. But I think what you're saying about involving people and having people in from the get-go and having buy-in is really key.
Yeah, and I think earlier on I mentioned it's about sharing of information and sharing the knowledge. And for somebody to be looking at a P&L account with the OEE and not share the information to the people that can change those figures is you know, it's good. So what we've done is bring this information to people, and Evocon has been a great help to capture the information and to share it around the factory. It's been quite a positive thing. I'm not here to sell Evocon to anyone. I'm just saying we use it, and it's been great for us. It's been great for us to measure and to manage and to share information with the people.
Thanks,
Guys,
Neil.
it's just 2 o'clock. That was fantastic. Hour flew by. I hope for some of you it's a very practical demonstration of OEE, because a lot of people shy away from the concept, but the idea today was to just give you a case study. As I say, we want to put this up on the network YouTube channel. I think that's it for this year. We'll have another event in January. I can't remember which one that is now. Again, that'll be posted out to everybody in due course. As I say, this will be put up with all the contact details, and we can share Sam's presentation and maybe Dave's and Mick's if that's possible as well. Thanks everybody, and if we don't see you, have a great Christmas.
Thanks, everyone.
Cheers, Dave.
Bye-bye.
Cheers. Thanks.
Thank
Cheers.
you. Bye.
All the best.
Thanks.